Can you believe your eyes? The prosthetic limb you're looking at is so realistic it's almost indistinguishable from the real thing. Selling for up to $8,000, every detail, from the texture of the skin and the distribution of leg hair to the natural curvature of the toenails, is a perfect one-to-one replica. Today, we're going behind the scenes to see how this functional work of art is built step by step. The journey begins with a client who lost his left leg. He arrives at this world-leading prosthetic manufacturing facility in a wheelchair, where he's met by an expert technician. The first priority is to capture precise data from the residual limb. The technician begins by fitting a gray socket, ensuring a seamless and perfect connection between the prosthesis and the body. To ensure an accurate reproduction, the entire leg is wrapped tightly in plastic film. Using a red marker, the technician identifies skeletal landmarks and joint stress points. This isn't just random sketching. Each mark corresponds to a key anatomical structure that directly impacts the comfort and functionality of the final prosthesis. Following the marking, a series of meticulous measurements are taken using tape measures and calipers. In this business, there is no room for even a single millimeter of error. Next comes a traditional yet crucial step: plaster molding. The technician applies plaster bandages, wrapping the client's leg layer by layer. To prevent any mix-ups, he clearly labels the cast LT for the left leg, a level of detail that would satisfy any perfectionist. Once the plaster has slightly cured, it is carefully cut away to reveal a perfect negative mold. Simultaneously, the team captures the curvature of the sound foot because symmetry is king. They use a specialized silicone with excellent fluidity to capture every subtle trace of skin texture and pore. The orange material looks almost like mango pudding or cheese sauce, but once it cures, it yields a perfect negative foot mold, clear enough to see every detail, down to the dry skin on the soles. With the negative molds ready, it's time to create the positive casts. An isolating agent is applied to the inner walls to prevent sticking before a high-strength gypsum slurry is poured in. This process is like baking a cake. The molds must be vibrated to ensure no air bubbles remain, guaranteeing absolute accuracy. After the plaster solidifies, the master technician breaks away the outer shell to reveal a perfect cast of the leg and foot. The real test begins with the refinement process. Comparing the plaster to the original markings, the technician uses specialized tools to grind and trim the model. This is a tedious, high-stakes process requiring extreme patience and spatial awareness. Every shave and scratch is done to maximize future comfort. After sanding it smooth, the model is wiped down and treated with a white lotion, giving it a deep hydration spa that looks more like a high-end dessert prep than industrial manufacturing.
The cast is then sent to a specialized oven for drying and curing. Now that the mold is perfect, the construction of the actual prosthesis begins. Using a vacuum system, the technician heats a softened plastic sheet and presses it over the plaster cast. The vacuum pulls the plastic tight, forming a transparent check socket. This allows the technician to visually inspect the skin-to-socket contact when the client tries it on, allowing for real-time adjustments. Once the fit is verified, they move to the final component, a carbon fiber socket made from the same high-tech material used in supercars. Layers of carbon fiber cloth and specialty fibers are wrapped around the plaster cast like an industrial lasagna. Metal connectors are cleverly embedded, the pinnacle of industrial aesthetics. Epoxy resin is poured in under vacuum pressure to fully saturate the fibers. Once cured, the result is an incredibly light and hard-coated carbon fiber socket. Then comes the grueling task of excavating the cast. Much like an archaeologist, the technician uses a hammer and chisel to smash the interior plaster model bit by bit until the carbon fiber shell is empty. Various grinding tools are then used to make the edges round and smooth to prevent skin irritation. Sparks fly everywhere. You'd think they were modifying a racing exhaust pipe rather than a medical device. The core assembly is next. The carbon fiber socket is connected to a high-tech pylon and foot unit. Every screw is tightened with a torque wrench to exact specifications to ensure safety and reliability. After assembly, the technician helps the client don the brand new prosthesis. This is a monumental moment. Between parallel bars, the client begins adaptive training, moving from shaky steps to skilled strides. Every movement, from navigating slopes to climbing steps, is a lesson in reclaiming daily life. Seeing a client walk outside again is a powerful reminder that technology truly changes lives. But we're only halfway there. The face project has yet to begin. The team uses a high-definition 3D scanner on the client's healthy leg, capturing every inch of skin and muscle contour in real time. Designers then mirror this data on a computer to create a perfectly symmetrical limb shell. This is far more accurate than traditional hand carving. To create the skin, flesh-colored silicone is repeatedly flattened and stretched in a machine, looking exactly like someone making ramen or Indian flatbread. This silicone skin is then fused onto the prosthetic structure using specialized tools, much like applying a screen protector to a phone, but with surgical precision. The seams around the toes are meticulously tucked in to ensure a seamless fit. The entire model is then placed in a transparent box where liquid silicone is injected for secondary shaping before being baked in the oven like a Peking duck. The result is a lifelike silicone foot, but the obsession with detail doesn't stop there. The toenails are crafted separately, matching the exact shape and thickness of the original. A manicurist-level technician glues these nails onto the silicone toes one by one with extreme focus. Next is the most incredible part, the leg hair. Tiny bunches of black thread are implanted one by one into the silicone skin with forceps. They even adjust the direction and angle of each hair follicle to mimic nature. This isn't just manufacturing, it's creation. Finally, the makeup session. Technicians match the client's skin tone to create a unique paint using a spray gun to apply multiple layers. From deep skin tones and surface spots to the subtle dullness at the toe joints, everything is restored. A makeup brush is even used to apply powder, setting the color and giving the skin a realistic matte texture. It looks less like a factory, more like a Hollywood special effects studio. After a final 7-minute bake to blend the colors, the excess powder is rinsed off and the leg is blown dry. The hyper-realistic skin, complete with nails and hair, is finally fitted onto the carbon fiber skeleton. The final interface is adjusted to be seamless, even simulating blood vessels and skin blemishes. After countless hours of labor, this $8,000 leg has completed its rebirth. Back with the client, the technician performs a final on-site fine-tuning, matching the toenail color and skin state to the other foot. The attention to detail is awe-inspiring. When the client stands up and walks again with this flawless prosthesis, the confidence on his face is the greatest return on that $8,000 investment. This is more than a tool for walking. It's restoration of dignity and a beacon of hope for reintegration into normal life. It goes beyond craftsmanship. It is the power of technology and art warming the human heart.